Okay, Assalamualaikum warahmatullahi wabarakatuh and very good day. So in this video, I'm going to discuss about the irrational number. So previously, we already learned about the construction of real number. So basically, the construction of real number based on the axiom. So basically, the axiom are divided into three parts. So namely, field axiom, order axiom, and also completeness axiom. So the completeness axiom I didn't discuss yet, so I will discuss in the next video. So we already look the definition of natural number and then integer together with rational number. So previously people believed that all the number can be written in rational way. So in the rational way means that you can write in the fraction of division of integer. So you can divide two integer, then you will get a number. So people believe that all the number can be written in this way. Okay, but this is not actually the case. So let us look where the problem come from. So the problem come from this very simple triangle. So in which we have this side and this side is equal to 1. Okay, so based on the Pythagoras theorem, when this side is 1 and this side is 1, so we have 1 square plus 1 square is equal to 2. So therefore, to get the value of this side, we need to find a number. When we square, it is equal to 2. So of course the number we can write square root of 2, right? Because if we take square of 2, it will become 2 again. Okay, so now we already have the notation square root of 2. But what is the square root of 2? So how can we write square root of 2 in terms of fraction? So somehow here the people cannot write square root of 2 as a fraction. So people try and try, keep on trying, but somehow they cannot write square root of 2 is in terms of fraction. So in terms of fraction means that you have some integer number divide another integer number. So this will become a problem for them, and they do not know what is the number of square root of 2. So now I would like to share with you these two videos, so you can watch after this about the explanation how they came out with this irrational number. Okay, so now my aim in this video is to prove that this square root of 2 is not rational at all, means that you cannot write in terms of fraction. So first of all, to get that result, I need some auxiliary result, which is the following lemma. So this lemma say that let m in natural number, then m square is even if and only if m is even. So now we are going to prove this lemma. So in this lemma, we have two things here. So first one, or the first statement is that m is even if so m is even if m square is even if m is even. So the next statement is that if m is even, then m square is also even. So here we have these two statements. I just said this now. Now to prove the first statement, if m is even, then m square is even. So this one is quite obvious, and I already explained in the last video where I used this example to prove to show the example in the direct method. So you can prove m is even, then m square is even by using the direct method. Okay, now I'm going to apply, or I'm going to prove the second statement here. So if m square is even, then m is even. So to prove this statement, I'm going to use the contrapositive technique. So recall again, we need to write the contrapositive of this statement. So this statement say that m square is even, then m is even. So therefore, the contrapositive of this statement would be if m is not even, then m square is not even. So we are going to prove this statement inside this instead of number 2 here. So because I think it's quite difficult to directly prove m square even then m is even, and it is much more simple if we treat this statement by using the contrapositive, which is if m is not even, then m square is not even. So what do we mean by m is not even? So it is mean that m is odd, right? So when we say that m is odd, m can be written as equal to 2k plus 1 for some integer k. So therefore, taking the square of 2k plus 1 and rearrange like this, we are going to get something like that. Okay, so we have 2 multiplied by some number here plus 1. So of course 2 multiplied by some number is going to be an even number, plus this one is going to be odd again. So means that here m square is odd. So we already proved the statement that we want. We start from m is not even. Then we prove that m square is odd. So therefore, this statement, contrapositively, it is equivalent to m square is even, then m is also even. So we prove the statement number 2. So basically, we prove this lemma, m square is even if and only if m is even. Okay, so now we come to the most important part of our lesson, which is we want to show that the value square root of 2 is not a rational number. So we are going to prove this one by contrapositive. So to prove this one, we suppose the opposite of what we want to prove. So we want to prove it is not rational, right? We want to prove that one. By contrapositive means that we are going to assume the other way around, which is we suppose that square root of 2 is a rational number. So when we suppose square root of 2 is a rational number, means that it can be written as a fraction of 2 number, which is square root of 2 equal to a over b. So let's say that this is in the simplest fraction, because when we write a number, we can write in in many form, right? So for example, if we have let's say that we have 4, so 4 also can be written as 4 over 1, or also 4 can be written as 16 over 4. So it is also equal to 4. So that's why when we say a rational number, we can write in different form of fraction. Okay, understand? So therefore, in this case, we suppose that this fraction a over b is already in the simplest form. So in the simplest fraction. Okay, and b, of course, b cannot be equal to 0. So next, we are going to apply square both sides. So we will have 2 equal to a square over b square. Rearrange this one, I will get a square is equal to 2b square. So this implies that because a square is equivalent to of b square, so mean that a is a multiple of 2. When a is multiple of 2, of course a square is even. So based on the lemma here, when m is even, then m is also, when m square is even, then m is even. So here I know that a square is even. So automatically, based on that lemma, it's implied that a is also even number. So this means that a can be written as 2k, because a, we know that it is even number. So when we know that a is equal to 2k, we are going to substitute into this part. So instead of a, we are going to replace with 2k. So we will have 2k equal to 2b. So expanding or open the square here, we will have 4k square, and rearrange this one, we will have 2 cut with 2, then we will have 2k square equal to b square. So this also implies to me that b square is equal to 2k, means that b square is multiple of 2. When b square is multiple of 2, means that b square is even. So again, using that lemma, when b squared is even, so b is also even. Hence, a contradiction here. So why it is a contradiction? So you can pause the video for a while and think why I say that this is already a contradiction. When we found b is already even, then it is a contradiction. So you can pause, think for a while. Okay, so if you have the answer, good. So the answer is that if b is, so we found that here b is even, right? So if you recall again, here previously we know that a is also even number. So what do you mean by here? So b even number, a is also even number. So it is not right there, because when a is even number and b even number, of course these two fractions can be further simplified, even though we say that this fraction is already in the simplest form. So therefore, the contradiction here. Why we have this contradiction? Because we already assume here square root of 2 is rational number. So we cannot assume that part. We cannot suppose that square root of 2 is rational number. So therefore, the things that has to be is that square root of 2 must be irrational number. So that's why we already proved square root of 2 is an irrational number. Okay, so this theorem, you can look, so the proof is given in the book, and here is some kind of graphical explanation on the numbers that we have. So basically we start with the natural number, whole number, so integer. So of course integer included all the negative number together with 0 and natural number, and then we have the rational number. So previously people are known here, but when they found about the square root of 2, then we know that real number composed of the rational number together with the irrational number. Okay, so I think that's all for my video. Thank you for watching.